Section 4.3 Logarithmic Functions. In this section, you will convert from logarithmic to exponential form, convert from exponential to logarithmic form, evaluate logarithms, and use common and natural logs. Let's have a quick refresher. Are exponential functions one-to-one? Let's start with a graph of an exponential function. You learned this from the last section, 4.2. You have a horizontal asymptote here, and this is an example of a graph of an exponential function. So how do we check if an exponential function is one-to-one? Yes, remember the horizontal line test? It is a one-to-one function if it has only one x value for each y value. So let's try. Look at these horizontal lines. There is only one x value for each y value. So yes, it is one-to-one. So do they have inverses? Yes. And that is the inverse of the n exponential function is what you call the logarithmic function. That is log base b of x. Visual way to think about it, log base b of x is equal to y so think b raised to y, b to the y is equal to x. So that base b here, that is the base of your exponential, b to the y is equal to x. Now, how do we get our domain and range of a logarithmic function with a base b? I'll show you a graph of an exponential function using decimals. Let's say y equals with a base b with a base 2 raised to x. So this is an exponential graph and showing you some values from -2 to 2 with all these points, and we know that the inverse of an exponential is a logarithmic function. So I'm going to type it here, y equals log, the base is, let's use the base is 2, so underscore 2 of x. So the red graph is the graph of the logarithmic function. So if I show you again table of values, you will see here that below 1 or 0 and below, you will see here are all undefined. So based on this graph, also you can see that they are inverses, y equals x. So we want to get the range and domain of the logarithmic function. So this is the logarithmic graph, and since below 1 is undefined, 0 and below, so meaning we have a vertical asymptote at x is equal to 0. So we can say that, what do you think is our domain and range? So this is the graph of log base 2 of x. The domain of the logarithmic function with a base b is, yes, that is from 0 to infinity, and the range is from -infinity to +infinity. Okay, quick check number 1. Can we take the logarithm of a negative number? That is something like log base b of -1. So earlier, remember, I showed you the table of values using decimals, and the answer is no. So think about log base 10 of a negative 1 is equal to y. If we switch this to exponential, 10 raised to y, is this equal to negative 1? Can you find the number y? 10 raised to that number is equal to negative 1. So there is actually no solution. Okay. Next, converting from logarithmic form to exponential form. Let's get practice moving back and forth between exponential and logarithmic equations. Letter A. Log base 6 of the square root of 6 is equal to 2. So let's use this with the base b. So that's also your base here. 6 raised to 1/2. Is it equal to the square root of 6? And the answer is yes. Letter B. Log base 3 of 9 equals to 3 squared. Is that equal to 9? Yes, 3 times 3 is equal to 9. Let's have another problem here. Log base 10 of a million is equal to 6. So let's rewrite that to exponential form. 10 raised to 6, that is, with 6 zeros, yes, it is a million. And log base 5 of 25 equals 2. So you can rewrite it as 5 squared, and 5 squared is equal to 25. So that is a yes. Next, let's try this time converting from exponential form to logarithmic form. Letter A. 2 cubed is equal to 8. So rewriting this to logarithmic form, the base is 2, so that should be the base of your log, and this is the exponent, so that is going to be the log base 2 of 8 is equal to 3. You can check if you want using the arrows. We know that 2 cubed is equal to 8. So that is letter A. Letter B. B squared equals 25. So log, the base is 5. So that's going to be your base here also. And the exponent is that 25 is equal to 2. And again, you can double check this. 5 squared is equal to 25. Okay, letter C. 10 raised to negative 4 equals 1 over 10,000. So that is log, the base is 10. So let's write base 10 here. And this is going to be your exponent. 1 over 10,000 is equal to negative 4. And yes, ten raised to negative 4 is equal to 1 over 10,000. Let's have a quick check here. Write the following exponential equations in logarithmic form. 3 squared equals 9. So that is log base 3 of 9 is equal to 2. The next one, the base is 5. So log base 5 of, yes, this is your exponent, 125 is equal to 3. And letter C, 2 raised to negative 1 is equal to 1/2. So yes, log base 2 of 1/2 is equal to negative 1. Next, evaluating logarithms with and without calculators. In practice, we will use a calculator to evaluate logarithms, but we can also often evaluate them using our understanding and converting to exponential form. Let's try example number 3, y equals log base 4 of 64 without using a calculator. So we know that we can convert this to exponential form. The base is 4. So remember that is 4 raised to y is equal to 64. And then now what is that number when you raise 4 to that number is equal to 64? Yes, 3, because 4 times 4 times 3, 4 is equal to 64. So we can say that log base 4 of 64 is equal to 3. Okay, let's try these examples A and B. Letter A, evaluate y equals log base 121 of 11 without using a calculator. So let's try, since 121 is the base, we can rewrite this as 121 raised to y is equal to 11. What is that value of y when we raise 121 to that number is equal to 11? Yes, 121 raised to 1/2 is equal to 11. Square root of 121 is equal to 1/2. So don't forget, square root of 121 is equal to 11. So the answer is 1/2. Letter B, evaluate y equals log base 3 of 1/27 without using a calculator. So we know that the base is 3, so we can rewrite this as 3 raised to y is equal to 1/27. And we know that 1/27, we can rewrite 27 as 3 cubed, because 3 times 3 times 3 is 27. And 1/3 cubed is the same as 3 raised to -3. So we can say that 3 raised to y is equal to 3 raised to -3. And now y is equal to -3. Next, using common and natural logarithms. The two most used base of logarithms that we will use are the base 10 and the base e. So common log, y equals log x is equivalent to 10y raised to y equals x. So meaning the base here is 10. Okay, example here, evaluate y equals log of 1,000 without a calculator. So again, if you don't see a base, meaning the base is 10. So let's use this. 10 raised to y is equal to 1,000. 10 raised to what number is equal to 1,000? Yes, y is equal to 3, because 10 cubed is equal to 1,000. Next, evaluate y equals log of 1,000,000 without a calculator. So again, think that your base here is 10. 10 raised to y is equal to 1,000,000. 10 raised to what number equals 1,000,000? Yes, that is equal to 6. 10 raised to 6 is equal to 1,000,000. Next, evaluate y equals log 327 to 4 decimal places using a calculator. using 4 decimal places. It's going to be 10 raised to y is equal to 327. And if you use a calculator, it's going to be approximately equal to 2.515. So that means 10 raised to 2.515 is equal to 327. I'll show you using decimals. You just type log of 327. You will see here that is equal to 2.515. Okay. X is natural log. This is ln. And y equals ln x is equivalent to e to the y equals x. Say that ln of x is equal to log base e of x. Okay, and we know that e is approximately equal to 2.718. Let's try this example. Evaluate y equals ln of 500 to 4 decimal places using a calculator, and you'll get an answer approximately equal to 6.214. That is because e raised to 6.214 is equal to 500. Okay, I'll show you using decimals. So here just type ln of 500 and you'll see that that is equal to 6.214 or 2.215. Also, you can use e raised to 6.214 or 2 is almost 500. Okay. Now let's try some more examples here. For the following exercises, we write each equation in exponential form. Number 8, log base 16 of y equals x. We do the arrows. 16 raised to x is equal to y. Same thing with number 10, log base y of x is equal to negative 11. So that is y, this is now the exponent, raised to negative 11 is equal to x. Next, for the following exercises, we'll write each equation in logarithmic form. Number 21, n to the power of 4 is equal to 103. So the base here is n. So that's going to be the base of your log base n. And this is going to be your exponent of log base n of 103 is equal to 4. Number 25, base is e, so log with base e, and this is your exponent of h is equal to k. Or you can write this, if your base is e, you can write this as, yes, ln of h is equal to k. Next, for the following exercise, solve for x by converting to logarithmic equation to exponential form. Log base 2 of x is equal to 6, so 2 raised to 6 is equal to x. And what is 2 raised to 6? Yes, 2 times 2 times 2 times 2 times 2 times 2 is equal to 64. Next, 31 log base 9 of x is equal to 1/2. So 9 raised to 1/2 is equal to x. And we know that 9 raised to 1/2 is the same as square root of 9 equals x, and square root of 9 is 3. Okay, last one. Answer the question and justify your response. Is x equals 0 in the domain of the function f of x equal log of x? If so, what is the value of the function when x is equal to 0, and verify the result. The answer is no. So remember, a graph of a logarithmic function, you have a vertical asymptote at x is equal to 0. This is the graph of your logarithmic function, and you can see here that x is not in the domain of the function log of x. So just to recall, the domain here is from 0 to positive infinity, and also range is from negative infinity to positive infinity. Okay. Alright, that's it for section 4.3. Let me know if you have any questions. Thank you.